All right, I am going to go over lesson 833. It's a longer lesson. It's supposed to be a 2-day lesson, so I'm going to see how quickly I can do it. Hopefully, I get it done in 2 videos, but I'm going to have to go somewhat quickly with some of these. The idea behind this lesson is really just using what we did in 831 and 832, the area of a circle, the circumference of a circle, and that area of a sector and that length of an arc, but it's all just word problems or application problems. Um, and so we'll get right into it here with problem 8-112. Okay, so it's saying, just as the intro, how can I use it? Like I said, it's just application of the problems that we've seen yesterday and before break. All right, so in lesson 831, you develop methods to find the area and circumference of a circle with radius r. During this lesson, you will work with your team to solve problems from different contexts involving circles and polygons. Well, the Earth's, 8-112, while the Earth's orbit path about the sun is slightly elliptical, it can be approximated by a circle with a radius of 93 million miles. So the first part A is saying, how far does the Earth travel in one orbit about the sun? So what is the circumference of Earth's path around the sun? And so to do this, I'm going to draw out what they're kind of saying here. Okay, so they're saying we have the sun here, and the Earth travels, and it's really elliptical, but we're saying it's a circle. It travels around the sun, that little black dot is the sun, with a radius of 93 million miles. And I'm just going to say 93 million miles. And we want to know the circumference of that, or the distance around. And so we said in lesson 832 that circumference has the equation 2 times pi times the radius. And so we have everything we already need, actually. We know already that the radius is 93 million, so to find circumference, we say that c equals 2 times pi times 93 million. Okay. And that's actually going to be kind of close to our answer already. I'm going to use a calculator here to do it. The circumference then is 2 times 93 million, and 2 times 93 million is going to give me 186 million. And we're going to tack the pi on at the end, and so that's 186 million pi. If I want to be using a decimal approximation, which in that problem it says I could do either, that would be approximately, 1 second, 584, sorry, my 8s are still bad, 84,336,233.5. Actually, let's round that to 234. Just round it up. Okay, and so there we have the circumference, or the distance traveled around the sun. 584,336,234, and I believe they're talking about miles. All right, and that's part A. Now in part B, it's saying approximately how fast is the Earth traveling in its orbit in space? So we want to figure out how many miles per hour is the Earth traveling around the sun. Well, first thing we got to find out is how many hours are in a year, because what we're saying in this problem is that the Earth is doing one orbit around the sun, and one orbit around the sun is a year. And so the first thing, like I said, is we want to find out how many hours in a year. And so first thing, there are 365 days in a year. So days per year. And there is 24 hours a day. If I multiply these together, the days will cancel, and I'll just be left with hours per year. And so, good start here. We have 365 times 24, and that gives me, let's do it right here, 365 times 24 gives me 8,760 hours per year. All right, now that's good because we have hours per year, and we actually in problem A figured out how many miles in 1 year it takes. 584,336,234 miles in 1 year. And what we can do to figure out how many miles per hour is we can just take our miles in the 1 year from our circumference and divide it by the hours, and we'll have miles per hour. All right, and so I take my answer from A, which I got to go back up and see again. 584 336 234. Those are my miles that it's traveled. I want to divide that by the hours. 8,760. Don't know why I went southern there. And if I do that division, I should be left with miles per hour. Miles per hour. And that gives me my calculator here. That gives me that the Earth is traveling 66,705. Let's just round it there. We'll leave it there, and it's kind of an approximation. Miles per hour. And that's an approximation because, like it said in the problem, the rotation around the sun is elliptical, not circular. So I'm a little off, but that's the idea here. We found the miles traveled around the sun, and then we figured out that there was 8,760 hours in a year. The distance traveled in 1 year is that circumference, which was that 584 million number. And then you took our miles divided by our hours, and so we got miles per hour, which ended up being at 66,705. All right, let's move on to the next one. So here's problem 8-113, a little different than 8-112. In 8-112, we were really just working with the circumference of a circle. Here we're going to be working with that area of a sector again. And if you don't remember from 8-3-2, the area of a sector is always we find the area of the whole circle and we multiply it by the portion we want. And the portion we want is always using that central angle out of 360. It was in the video for 8-3-2, but we'll see it again here in 8-3-3 as kind of almost a refresher. What it's saying is a certain car's windshield wiper clears a portion of a sector as shown at the right. The shaded area is the section that gets cleared by the windshield wiper. And it's saying if the angle of the wiper's pivot during each swing is 120 degrees, find the area of the windshield that is wiped during each swing. So really we are just trying to find that area of the shaded region. Okay, what we're going to do is we're going to find the area of the whole thing, shaded and unshaded, and then we're going to subtract out the unshaded. Okay, but again we're going to need to find area of a sector first. Okay, so first thing I want to see is the area of the whole thing, or the if we see this as a whole circle, sorry, it has a radius of 20. Okay, and I should put on here too, the area of a circle is, we just saw this yesterday, but the area of a circle is pi times r squared. Okay, and I just said that if we're talking about the whole thing has a radius of 20, 15 plus 5. Okay, so let's find the area of the whole thing. Area of the whole thing is pi times 20 squared. Sorry, squared. And 20 squared equals 400, so the area of the whole thing is 400 pi. Okay, that's the area of the entire windshield wiper, shaded and unshaded. Okay, Now let's just find the, oh sorry, that's of the entire circle, and we need to talk about just the sector. All right, and so 400 pi is the area of the entire circle, if that made an entire circle. But since this is a sector, we only want the portion that's shown. And the portion that's shown is 120 degrees out of the 360 degrees. All right, and so what we have to do here is multiply the 400 pi times the 120 over 360. That actually reduces down somewhat nicely, and so this becomes 400 pi multiplied by 120 over 360 actually reduces down to 1/3. And so when I multiply this, what this becomes is actually just 400 pi over 3 when you end up multiplying this right here. All right, and now that's the area of the shaded, unshaded, just that sector, okay? Now we need to find the area of the unshaded, this white part right here. We want to find the area of that, so we can take the whole area, subtract out the unshaded part, and we'll just be left with the shaded part. And so if I find that now, I got to do area again. I'm using my same area formula. A equals pi times the radius squared, but this time my radius is just 5. And so I plug 5 in for r, and I have area equals pi times 5 squared, which is 25 pi. Now that would be the area if this was the entire circle, but we're just looking at this portion here. In that portion, so since it's a portion, we have to multiply by what it is, and that's again 120 out of the 360 total. That reduces down like it did before, so this is 25 pi times 1/3, which ends up just being 25 pi over 3. So now I have my total area of that sector. I have the area of just the unshaded part and to find the area of the shaded part, let's take a look at it. To find the area of just that shaded part right here, I need to take the total area of the sector, so 400 pi over 3, and I need to subtract out the unshaded, 25 pi over 3. What that leaves me with is 375 pi over 3, which reduces down to 125 pi. All right, and I believe this is in, it's in inches, and so that's 125 pi inches squared. And that right there is my final answer. That is just the area of the unshaded. Okay, a lot of big things in this problem to recap starting back up top. We had to remember the area of a circle, pi times the radius squared. We had to use that to find the, if say this was an entire circle, we had to use that formula to find the area of the entire circle, which would have been 400 pi for the total thing. And then we multiply that by that portion or that sector. And that's kind of the part that I want everybody to remember, is that this is a sector, an area of a sector problem. And so we find the area, multiply it by that portion, which is always the central angle, over 360. I reduced it down and then got to my final answer, which was the 400 pi over 3. That is the area of shaded and unshaded together. I did this same kind of process again to find just the area of the unshaded. And I subtracted total minus unshaded to find shaded. And that gave me the 125 pi inches squared again because it is an area. Only 2 more problems in this lesson. The next one's a little bit longer. I'm going to put it on the next video. And I should only take 2 videos, hopefully. We'll see.